Here's the next question, number 35. The output of a continuous time, linear time invariant system is denoted by t into x of t, where x of t is shown as the input signal. A signal z of t is called eigensignal of the system t. When t into z of t equals gamma z of t, please note that's a gamma, where gamma is a complex number in general and is called an eigenvalue of t. Suppose the impulse response of the system t is real and even, which of the following statements is true? Now the key here is to note that it says real and even. The impulse response of the system t is real and even. And the options given talk about cos of t and sine of t being eigensignals and their corresponding eigenvalues. So in this case, what we have to do is first examine what kind of system it is, and the fact that it is even and real and even. And then we have to note what happens when we get cos of t, when we assume that cos of t is the input signal, and what happens when we take sine of t as an input signal. Okay, so let me just get a sheet of paper. Okay, so we begin with what's given, the impulse response. Now the question says that the impulse response is real and even. Now if it is real and even, that indicates that h of j omega is also real and even. Now h of j omega is the complex term given in the question. The question says that gamma is the complex number, right? So since gamma is the complex number, take h of j omega, which is also real and even. Now in the previous question we looked at what when a system is actually called real. It is a real system, I'm sorry, let me just write that again. A signal is called real when f of minus x equals f of x, and that indicates that it is conjugate symmetric. Okay, so only when it is conjugate symmetric will we say that the signal is real. And because h of j omega is real, since the impulse response is real, we can say that h of j omega is equal to h of minus j omega. You see the relation there? That means that it is conjugate symmetric, which in turn shows that it is real. Okay, so now let's assume that here we have a system, linear time invariant system. There is a certain input and we obtain a certain output. Now in terms of complex, we can write the input of x of t in terms of e, so that would be e power j omega naught t, and we obtain as the output h j omega naught into e power j omega naught t. Okay, so since this is real and even, that means that if we were to take the same system, LTI system, the same system with an input of e power minus j omega naught t, then the output response would be h of minus j omega naught times e power minus j omega naught t. Okay, so here you will have to note that h of j omega naught equals h of minus j omega naught. That's because that it is real. Again, reiterating that fact, which means that that is the point that should give you, should lead you to the solution, to find the right answer. Okay, so now we have to evaluate what happens when the input is cos t and what happens when the input is sin t. So let's start with cos t. Now cos t is the input. So you will have to recall how cos t is written. Now cos t is written in terms of e as e power jt plus e power minus jt divided by 2. Now this is the input, okay? So if we pass this signal in the LTI, this is what we obtain. Now in regards to this, let's write the output. So the output would now be h of j times e power jt plus h of j e power minus jt divided by 2. Exactly the same. Now let's take h of j out as a common term. Now if we take this out as a common term, we get e power jt plus e power minus jt divided by 2. And that leaves us with h of j times cos t, because this is again the input cos t, and that gives us hj cos t. Note that the output given in the question is exactly this form, gamma times z of t. Gamma is our complex number into z of t, which in the question is the input, and the input here we have considered as cos of t. Okay, so that means that satisfies. Now let us check with sine. Okay, so we have worked out with cos. Now it is time for sine. Okay, so let's take the input as sine of t. Now the expansion of sine of t in terms of e is e power jt minus e power minus jt divided by 2j. You should note that the denominator has the complex term 2j. Okay, so if we give this as the input this time, what happens to the output? Now the output would be h of j times e power jt minus h of minus j e power minus jt minus divided by 2j. Let's take h of j common here. Okay, so we will obtain e power jt minus e power minus jt divided by 2j. Okay, we can consider this as h of j, fine, not a problem. So here we have h of j times sine t, because it is exactly same as the input. So this tells us that both sine t and cos t satisfy the system given. Here it says that the signal z of t is called the eigensignal of the system. Now we have taken two eigensignals, both of cos t and sin t, and we have seen that the output corresponds to what is already given here, gamma, which is a complex number times the input. So this means that both sin t and cos t are eigensignals and they have the same eigenvalues. So that corresponds to option D here. Cos t and sin t are both eigensignals with identical eigenvalues. I hope this has helped.